Hello students, I'm Gonzalo from Wake 2D IB and CAIE Online Academy. Today we're going to see how to solve the free response section of the 2018 AP Calculus AB exam. This is divided in several videos, so make sure you watch all of them. In this video, I'm going to solve the parts C and D of question 5 of exercise 5 in the free response section without calculator of the 2018 AP Calculus AB exam.
Part C. In exercise 5, let f be the function defined by f of x equals e to the power of x times cosine of x. We have to find the absolute minimum value of f on this interval from 0 to 2 pi. First of all, we have to consider that the minimum value could be a relative minimum. So we have to find the possible critical points that are a minimum. And for that, we need to equal the first derivative to 0. E to the power of x will be a common factor. Okay, e to the power of x times and then cosine of x minus sine of x. This has to be equal to 0. There is no way that e to the power of x will be equal to 0 because it doesn't matter what the exponent is, it will never be 0. So we can cross this, we don't consider this one. Then we want to see when the cosine of x minus the sine of x will be equal to 0. Basically, we need to find values of x angles that have sine of x equals to cosine of x. Angles that have the same cosine and sine, and those angles are x equals pi over 4 and also x equals 5 pi over 4. Then these are two values of x that we can consider, and we need to find the value of the function for each of these values of x. If you substitute pi over 4 in the function, you will what you will get is 1 over square root of 2 e to the power of pi over 4. You just need to substitute. Okay, substitute cosine of pi over 4 is 1 over square root of 2 times e to the power of pi over 4. And then if you substitute the 5 pi over 4, what you will get is negative 1 over square root of 2 times e to the power of 5 pi over 4. These are the two values of the function. However, the relative maximum and minimum are not enough. The minimum could be at the beginning or at the end, because remember, we are just considering the interval 0 to 2 pi. So it could be that the maximum or the minimum is at 0 or at 2 pi. So we also need to find the value of the function at those points. If you substitute the 0, you will see that the function at 0, e to the power of 0 is 1, and cosine of 0 is also 1, so it's 1. And if you substitute 2 pi, you will see that the function at 2 pi is e to the power of 2 pi, because cosine of 2 pi is also 1, so times 1. Then, if we consider these 4 points, we have to see which one is the lowest point. We need to see which one is the minimum. And then if we check all of them, since this one is negative, then none of the other points can be lower than this one. Then we can say that the absolute minimum value of f on 0 to 2 pi is negative 1 over square root of 2 times e to the power of 5 pi over 4. Part D. Let g be a differentiable function such that g of pi over 2 is equal to 0. And we also see the graph of the derivative of g. It's shown here. Find the value of the limit when x approaches pi over 2 of f of x divided by g of x, or state that it doesn't exist. The first thing we can try to find a limit is just substitute. So if we substitute pi over 2 in f of x and in g of x, we don't really need to substitute it in f of x, because if we realize that g of pi over 2 is equal to 0, then we'll see that it's something over 0, which means it's going to be undetermined. We can use L'Hopital, okay, and L'Hopital rule. According to this rule, the limit of these two functions, f over g, when x approaches pi over 2, will be equal to the limit of the derivatives of f and g, also when x approaches pi over 2. In the previous section, we found the derivative of f. We have it here, so we don't need to find it again. We can just use this one, and we have to find the derivative of f at pi over 2. And if we substitute, it's e to the power of pi over 2, and then cosine of pi over 2, as you know, or you can calculate it, cosine of pi over 2 is 0, and then sine of pi over 2 is 1. Okay, so basically this part will be eliminated, okay, and we can just use the second part. So the derivative of f at pi over 2 is going to be negative e to the power of pi over 2. Then if we substitute this in the limit, okay, limit when x approaches pi over 2, and then negative e to the power of pi over 2, and then we also need to know the value of the derivative of g at pi over 2. As you read in the question, you can see the graph of the derivative of g, which means we just need to check what is the value in the graph when x is pi over 2, and as you can see, this is the point. The value is 2, which means the derivative of g is 2, and we can just substitute it in the denominator. Well, this is actually the limit, minus e to the power of pi over 2 over 2.
Thanks a lot for watching, and please watch the next videos where I will finish the remaining sections of this part of the exam. Also, don't forget to register for free demo on our website www.waketoryonlineacademy.com.